Now observe the air as it goes down through the house. It will start moving away from the inlet going towards the fanned end of the house. Okay, now we're going to be looking at tunnel ventilation, and in this case it's with evaporative cooling. Now you'll notice in this case the curtains are all the way to the floor. Number one, we don't ever want the curtains to be closer to the floor than 3 feet. The main reason for that is we don't want the chickens to feel the airspeed entering the house. We want the chickens to feel the airspeed going through the house. So when the curtain is allowed to be open all the way to the bottom, or the curtain is open from the bottom up, then we've got too much airspeed that comes in on the chickens in this area of the house. So we don't ever want the curtain to be lower than 3 feet from the floor. Now, we'll also look based on the surface area of the pads compared to the fan capacity. In this case, the inlet curtain probably should never be open more than about 36 inches. So if we look at the pressure here now, see with the curtain all the way down, we virtually have, instead of having air entering the house at 900 feet a minute, we've got air entering the house at only 500 feet a minute. When we turn the inlet system back on and it adjusts the curtain, then we'll show you again how to measure the airspeed of the inlet coming in. And the biggest problem that we have here when the inlet curtains are all the way down to the floor, we don't have enough restriction. So what it does above everything else, it creates bird migration. So if the birds can feel the air coming into the house, they tend to want to migrate to this section of the house. So it creates migration. Another problem that if we don't get our pressure right, on each sidewall just past the inlet curtain down here going towards the fans, on each side of the house and right against the end door on this end of the house, there will be no air. And if we measure the air velocity right out in the center of the house, just past the inlet system, will be the highest airspeed in the entire house. So to balance the system, we use this inlet curtain to make the air distribution through the house be what it should be. All right, what we're going to do now is we're going down to the inlet area of the house, and we use smoke, as you've been seeing already, to allow you to see the air. And we're going to let smoke come in both sides of the houses down there, and you'll see the smoke come from one side to the center of the house, from the other side to the center of the house, and then it'll leave that end of the house and come through the house even all the way. And the smoke that we use happens to be this size smoke candle right here. And the thing produces 40,000 cubic feet of smoke. So that's the reason we're able to allow you to see the air as it moves through the house. When we get in the tunnel ventilation system with big chickens, people attempt too many times to ventilate the chicken house to satisfy people. And we're not ventilating to satisfy people, we're ventilating to satisfy chickens. So what we want to do is we can have high wind speed if we have high temperature, but we cannot allow high wind speed when we've got low temperature, or we'll either set all of the chickens down or we'll move all of the chickens out to the sidewall and they don't eat and drink. And when that happens, you lose your efficiency. So you have to make sure that based on the effective temperature chart, that your airspeed and your temperature that you've got set on your controls work together in every case. Okay, I want to make 2 or 3 other observations about tunnel ventilation. People get the idea that if they tighten the inlets up and increase the airspeed coming into the house, that in return they increase the airspeed going through the house. And that's totally wrong. If you increase the pressure of the inlet system, then you actually decrease the fan capacity. And when you decrease the fan capacity, you actually slow the airspeed going through the house down. So the highest pressure that we want to use in any chicken house is what it takes to get the air to the center of the house. Now, when we talk about the pressure that we rate fans at, for example, there's 4 that we have to add together. So it starts with the shutters and resistance through the house and through the pads and through the inlet curtain. So we only want to use the pressure that's necessary to get the air to the center of the house. That way we get by far the highest air volume and the best air distribution through the house. All right, what we're going to talk about now is the installation and sizing of the evaporative cool pad. And there's basically 2 pads that we use, and one is a 45-15, which you see on this particular house. And that's by far the best pad to use when you're subject to low humidities, from mid-range to low humidities. And then there's a 30-30 pad that's available, and that's normally the best selection when you're in high humid areas because of the way the water flows. And when you put an odd slope pad on the house, like a 45-15, your steeper slope or your 45-degree angle has to be to the outside of the house and to the ground. If you got this particular pad in upside down or backwards, you wet your floors inside the house and don't get good cooling. So you have to flow the water against the airflow as it goes through these pads. Now, when you install it on this doghouse, the minimum distance from the side of the house to the face of the pads has got to be 24 inches. We recommend 36 inches so you'll have plenty of room to get in there. We come out and measure the airflow through the house, through the pads, and with all of the fans running, the minimum speed through the pad should be 350 feet a minute. The maximum should be 450 feet a minute, and the closer we get to 400 feet a minute, the better the evaporation rate's going to be, so the more you can drop your house temperature without increasing your humidity. Now, all around the surface area of your pads, whether it be under your water recovery system or above your pads into your doghouse, it needs to be as airtight as possible, because we want all of the air that enters this house to enter it through the pads and not around the pads. And we don't want huge gaps between each pad. Now, if you ever drive up on the farm and you can see water running down the face of the pad, then the system shouldn't be running to begin with. The humidity's either too high or your temperature's too cool, so your evaporation rate is not nearly what it should be. So the key to cooling the house without increasing the humidity is the way these pads are, number 1, sized, number 2, managed, and number 3, installed. If you install the cooling pads too close to the side of the house and you try to use your inlet curtain to adjust your house pressure, then what you will actually do is shut the air off the bottom part of the pad, so you alter the surface area of the pads, and the surface area should never be altered. Now, also is on your inlet opening, the top of your inlet open entering your house shouldn't be any different from the top of your pads. We don't want this opening to be above the top of the pads. So in this case, they're even. If this was higher, what we would do is add a permanent curtain at the top to get the inlet open down even with the top of the pads. And the reason for that is up here in the top of this vestibule, the air is extremely hot because it's outside. And if the air comes up between this curtain and the pads and goes up and comes back in the house, it actually increases the temperature that you've dropped through the pad. It increases it. When you control this with the height of your pad, it makes the air enter the house without going up to the top. And what happens then here, when you get your curtain adjusted properly, as the fans control comes on and off, then these curtains will automatically adjust to keep the house pressure the same regardless of the number of fans. And I don't know if you can see it or not, but see this right here? We've got a hem in the curtain right here. We got a hem here, we got a hem here. Down here, we've got another hem. The reason we do this is to ensure that the curtain opens and closes straight and uniform with the fans on and a pressure in the house. So we put a regular curtain conduit in this, and in the next hem, the next two hems, we put a solid rod to weight the curtains to make it come in right. So when we measure our pressure drop coming into this house, we want to measure our pressure where the air enters just about 10 inches to a foot above the curtain. Now, on this instrument, if you let the air cross this port and this port at the same time, then the instrument's not accurate. So we don't hold the instrument as such and try to measure the pressure. So we either protect that with our hand, or we protect it with the post to where we don't have air crossing both. And you'll see here, if we measure the pressure up here, and then we measure it down here, and then measure it down at the bottom, then we get to see there you're measuring all of the air coming up from the bottom, so the pressure's a whole lot higher. If we come up here and measure it about 10 inches, see, that gives us exactly 1,000 feet a minute, which is what we want coming into this house. So the principle is exactly the same. We want the air from this side and this side to come together in the center of the house, and then once that happens, it will leave the inlet end of the house and go through the house from one end of the house to the other, uniform from one side to the other. All right, another thing that I want to discuss is the question always comes up whether to run your pads or your pumps on your pads with less than all your fans running. So since the pad surface area is determined totally by your total fan capacity, you should never run the pumps on your pad unless all of your fans are in operation. Because, for example, if you had your pad size for 8 fans and the air through it was 400 feet a minute, and you only had 6 of those fans running, then the airspeed through the pads would be less than 200 feet a minute. Now, if we stand in front of the pads, we would feel like we were getting a tremendous temperature drop because we have the ability to sweat. So we feel the airspeed, we feel the evaporation of the moisture off of the surface area of our skin. Chicken can't do that. So if you get the airspeed too slow or too fast through the pads, then you alter the evaporation rate to the point, again, that you escalate your humidity completely out of sight. So we always want to make sure that all of our fans are in operation before we allow our pumps on the cooling system to operate, so the system will be balanced from one end of the house to the other. All right, what we're doing now is we're going to check the tightness of the house. because to make any ventilation system work properly, the first thing you got to have is the house has to be as airtight as possible. That's extremely important with minimum ventilation because you use a minimum amount of fan capacity to take care of your oxygen level in the house without your utility costs being high. So what I'm doing now is measuring the negative pressure to atmosphere in this house that's 500 feet long and 44 feet wide and 10 feet high. With one 36-inch fan running, I've got a pressure drop of a 0.05. Now we're going to turn on another fan. When the other fan comes on, you're going to see the pressure go extremely high. So I'm going to have to stop this up and we read the high side of this. All right, as you can see, the pressure went completely out of sight. So now I come back and stop this up and read the high pressure side of this control. And with two fans running and the inlets closed, as you can see there, we're just a little bit above a 0.10. In fact, we're almost at a 0.125. So that's excellent for a house this size with two 36-inch fans in operation. You need to do the same thing to your inlet doors. You need to do the same thing to your end doors and your shutters on your summer fans. Now what we're looking at here is a walk-in door on the opposite side of the house from the control room. And even though this is a real good door, look at how much air leaks that you've got under the facing of the door at the bottom, and you'll see in just a minute up at the top of the door. So we've got to have that door sealed as good as possible, or too much cold air comes in and goes direct to the floor. What we're looking at here is a minimum ventilation shutter on a sidewall fan. And if you see at the top, they tighten the fan housing too much, so we got a big gap that leaks at the top. And the main place we don't want it to leak is at the bottom of the shutter, so the cold air entering when the fan's off don't go directly to the floor. All right, here we're gonna look again at tightening up the house. And you can see how bad the smoke's coming in under that end door. And you see the air going straight to that fan over there. So to have a air leak that close to a summer fan just takes away the amount of air that comes from the other end of the house. And you can see that the side all around the door, in the middle of the door and under the door, it's severely leaking. And we're gonna go from here to one of these sidewall fans. And the sidewall fans in this case has the baffle type or the gull wing type shutters. And they don't leak as bad as a regular shutter. See, we take for granted that those shutters don't leak very much. But look at the air that's coming around those shutters. Now what's real critical is in the winter time, you've got to cover up your summer fans because it makes it too difficult to get the pressure right. So you can see it leaks all the way around and up and down around that baffle, even though it's got a rubber seal. Now we keep talking about wind protection on the outside of the house. We're outside here and the wind's blowing, and as you can see, we can't even make air go in the house because the wind either goes down the side of the house or goes over the top of the house. So we have to have all the wind protection that we can get. This is a wind protection on the outside of the minimum vent inlet or the transition inlet. That's extremely important when you're in high wind environments. And then some of the houses that's built has wind protection that runs the full length on the outside of the house to prevent the wind from either side from affecting the condition inside the house. This is the air meter that we test the pressure or the airspeed entering the house. So if you look on the black side of the instrument, it reads in pressure in inches of water. If you turn it over and look at the red side, it reads in feet per minute in air velocity. One is exactly the same. For example, if we're looking at a 0.06 negative pressure, that is always 1,000 feet a minute entering the house. And the way the system is set up, the way the meter is set up right here, is if you're on the side of the inlet, that the air is coming towards you. Now, if we wanted to use the same instrument to measure the actual negative pressure in the house, then we just move this over to this, and if we're on the outside of the house, stick this through the door or through the inlet, and now it reads exactly what the pressure is to atmosphere. So whether it's set like this or like this determines where you are compared to where the air is moving. So here, the air is coming towards you. With this hose over here, the air is going away from you. And the scale that's on this will never change. No matter where you see it, it will always be the same. Now, when you use the smoke candles, then you have to hold them with the pair of pliers, because as the air comes out of the smoke candle, it's extremely hot. So if you try to hold it by hand, you're subject to burn your fingers. So always make sure that you hold your smoke candle with a pair of pliers. What we're looking at here is the minimum ventilation control motor. We have one on either side of the house. So when sidewall fans are running, only the motor on the opposite side of the house is in operation. Then when we go to transition ventilation, both sides of the minimum ventilation system has to work, so we use both motors. And then for our tunnel ventilation inlet motor, we have a control motor that runs the inlet for summer ventilation based on negative pressure. Now we got one motor for that controls the curtains on both sides of the house. All right, what we're looking at here is one of the 6 temperature sensors in the house. And the temperature sensor should be down close to bird level. Now what we're seeing here is the backup thermostats to start the fans in case there's problems with the solid state control in the control room. Baffles in chicken houses should only be used to increase the airspeed through the house and lower the air exchange rate in the house with the same fan capacity by just reducing the cross section of the house and the total cubic volume. The quality of fans that's selected to be used in a chicken house is very important. The static pressure that they're capable of operating under, the airflow that they will produce at that pressure, and the efficiency factor in CFMs per watt. And you're seeing here an example of a summer fan and a minimum ventilation fan. So you need to always select the fan that's best suited for the application the fans are being used for, and they should always be certified by Best Laboratories. If you need any additional information other than this video, please contact your Cobb Ventris sales rep or technical service supervisor.